Dr. Leslie Reich and myself are going to divide up this presentation, and I'm going to give a brief introduction. Lycoming College's Clean Water Institute has been a part of the biology department of Lycoming College since 1999. We have staff, and also through our goals of service, education outreach, and research, technical research, we're able to, through grants, hire between 8 and 12 summer interns, and then work with students during the school year to reach our different goals. Next slide, Leslie. I wanted to give just a brief history of MS4 in Lycoming County. Lycoming County is here. This is a map of Pennsylvania MS4s. We're one of the smaller MS4s and one of the only MS4s in the North Central region. Next slide. In Lycoming County itself, this is the MS4 region. The different boroughs, municipalities, initially there were 10 that were involved initially with the project. Pennsylvania College of Technology has since received a waiver, but you can look at this map and see that here's the west branch of the Susquehanna River. You go 2 miles north or 2 miles south, and you're either in very heavy forested areas, mountainous areas, or are heavily impacted agricultural areas. With a strip here along Lycoming Creek and Loyalsock Creek over here. In addition, within the urbanized area, there are 9 urban streams that we are currently doing projects on in terms of monitoring. Next slide. The MS4 Coalition in Lycoming County was informally associated in 2003. In 2010, the county produced an Act 167 Stormwater Management Plan. The coalition itself was formalized in 2014 and included an MOU for a planner, but the planner position was discontinued after 2017 and included initially 10 partners. The CWI started an outfall survey that was part of the planning process, and the currently is of 2020, the MS4 group in the city of Lycoming County now includes 3 sort of groupings of constituents. So the city now has, the city of Williamsport has turned over its MS4 to the Williamsport Water Sewer Authority, and they're in partnership with Loyalsock Township. Part of that is that these 2 entities had an MOU to deal with combined sewer overflow. So they initially then kept on this cluster in terms of stormwater. The second entity includes South Williamsport and DuPois Town, which is managed by the Lycoming County Water Sewer Authority. And then finally, the peripheral sort of MS4 boroughs, municipalities, Fairfield, Hepburn, Lycoming, Montoursville, Old Lycoming, are under individual permits, although they are cooperating with each other. Next slide. Can we move forward?
Oh, yeah, sorry. My internet cut out for a second.
Okay, so in 2015, basically the county put together a joint MS4 plan, which they are still under now. Only these municipalities and boroughs are meeting their obligations at different permit rates. Next slide. So one of the things that we'd started, CWI started in 2015, was to survey and evaluate the number of locations of outfalls in the MS4 region. Some preliminary work was done by Pennsylvania College of Technology about 15, 20 years ago. And we were using then the next slide, the DEP form for looking at and giving a GPS location for all the stormwater outfalls going into the river or Lycoming Creek or Losac Creek or any of these urbanized streams, and then assessing the condition of the outfalls themselves, what the material they were made out of, if they were in good shape. We collected water samples if water was running through them. We were to go out and look at these outfalls when there hadn't been any rain for 72 hours prior. And basically, next slide, our overall assessment came up with 260 stormwater outfalls that were divided among the municipalities and boroughs where they occurred. And there's, as everyone knows, dealing with this, there's a lot of other pipes out there. So this list doesn't include jurisdiction from PennDOT, any of the stormwater outfalls that are associated with railroad supervision. Although some of the boroughs now have attached that onto their monitoring and assessment. So this report here was completed in 2016, and we've been going back and looking at a number of these outfalls in terms of our monitoring in our urban streams. So that's sort of an overview in a nutshell. We are currently, as I indicated, working under a grant from the Arthur Vining Davis Foundation, and what Leslie has been working with is sort of a review of the challenges posed to small municipality MS4 regions. So I'm going to turn it over to Leslie.
Good morning. So we already went through a lot of this in the introduction this morning, but I wanted to start out with basically what MS4 regulations are and where we start to understand the problem. When you read the regulations, it seems pretty straightforward. To the maximum extent practicable, you need to reduce pollutant discharges via BMPs and the implementation of 6 minimum control measures. And BMPs are structures that are designed to slow and filter stormwater as it enters. Examples would be bioretention systems, infiltration systems, and storage facilities, like retention ponds and constructed wetlands. And the minimum control measures involve public outreach, education, participation, and involvement, identifying illegal or illicit discharge and eliminating it from your watersheds, controlling runoff from construction sites, post-construction runoff control, so requiring that developed land has some kind of stormwater controls, and pollution prevention and good housekeeping. So that seems pretty straightforward. I mean, you know, you just do what you need to do and then it's done. But where's the problem here? And what we really found when we looked at, in particular, small municipalities is that the challenge is that you have essentially a non-point source of pollution in stormwater that falls everywhere. So it's a diffuse non-point source that also causes altered hydrology, originating within an urban land area using only local authority. So this is on cities to implement. Hang on. Is my screen still sharing?
Yes.
Okay. Because it just ended the presentation for me. It's a non-point source originating from relatively large land area that local authorities have little control over because a lot of them are private properties and there's very little funding to implement these actions. So you have something like this subdivision here where you have a couple hundred homeowners and you're asking them all to do something or trying to deal with the water running off their property after it runs off, which is kind of a fundamental problem and central challenge to these regulations. Small municipalities in particular, we found, are more likely to face challenges. There's a problem with stakeholder buy-in in a lot of regions. Smaller cities tend to be underfunded relatively, causing financial constraints, and it ends up hampering the formation of effective stormwater management plans. So we thought that identifying and describing some common challenges we could identify through talking to people from other regions and doing some literature review could help shift the focus to how to address this central challenge more effectively. So we identified 5 main challenges that small MS4s are more likely to face. The first is that the sources of impairment are largely agricultural. This is particularly important in areas like central Pennsylvania, where there's a lot of agricultural land. There's also a lack of funding, and the idea that this funding is a make or break thing. If you don't have money, you can't do it, and there's no direct funding, tends to cause a lot of hand-wringing. There's also a lot of perception, and some of it comes from the marketing of MS4 projects, that the projects only lead to downstream benefits. So there's really no local impact on the community. There's an issue where monitoring is overlooked because there's a concern that you'll find something wrong and have additional difficulties as a result. And also this perception that BMP projects need to be large to be effective, and that they need to be particularly expensive. So the first problem I want to address is that the source of impairment is largely agricultural, and that urban stormwater isn't as much of a problem, and it's unfair. So first off, agricultural runoff is a big contributor of nitrogen, phosphorus, and sediment pollution, and generally they're exempt from most federal water quality regulations. There's not, an MS4 program for farmers where they have to regulate their stormwater, and it is the largest contributor, at least in Lycoming County, because it covers so much land area. But urban stormwater does contribute nitrogen, phosphorus, heavy metals, herbicides, personal care products, pharmaceuticals, plasticizers, industrial chemicals, and just a slew of other chemicals and materials. So that really urban land disproportionately contributes pollutant loads to streams and rivers. For instance, we found the statistic that urban land area contributes 16% of the total sediment to the Chesapeake, in spite of only covering 8.8% of the drainage area. So really, there is a good reason to look toward urban areas when trying to control nutrients and sediment. And part of this causes an issue when you're trying to explain to stakeholders the importance of treating urban stormwater. It's really intuitive for most people to understand that nitrogen, phosphorus, and sediment run off of a farm field because they can see the soil and they can see the stream, and it's just natural that water runs off and carries it. It's less intuitive for a lot of people to understand the complex relationships between impervious cover, stormwater systems that they may not even notice, and the hydrologic changes associated with transitioning to urban land use. However, it's important to explain this because addressing urban stormwater on a per acre basis provides more bang for the buck. It's largely in storm sewer pipes, so it's easy to find, you know where it is. So in part, it's helpful that it does transition from non-point to some form of point source pollution. This really needs to be better incorporated, we think, into outreach and education, particularly in areas like Lycoming County that have predominantly agricultural land use within the county. So within this, we find that really solution with sources of impairment is that both land uses do contribute, and we need to better understand and better explain to stakeholders that both landscapes contribute to pollution. The second challenge I want to address is this perception that projects to treat or mitigate urban stormwater only lead to downstream benefits. In a lot of areas, particularly around here, there's a lot of emphasis on the benefits to estuaries, beaches, and coastal areas, particularly the Chesapeake Bay, which people around here, I'm sure, appreciate when they visit, but they want to see local improvements if they're paying for it. People generally don't notice their stormwater infrastructure, unlike other utilities, like their sanitary sewers or at any other normal utility that people are used to paying for. So improving it is invisible to some constituents, just because it's simply not something we're conditioned to notice. However, it's important when we talk to people and market this that really addressing stormwater provides numerous direct benefits to local streams and surrounding communities. For instance, this stream here in the image isn't really an asset to the neighbors. It's inaccessible and it's not particularly attractive or someplace you'd want to play. But improving our urban stormwater can increase water supply protection, flood mitigation, which, like the introduction this morning mentioned, is incredibly important as we look toward increased precipitation and climate change resistance. You can also have reduced erosion, property loss, and infrastructure impacts, including preventing aging of infrastructure, or premature aging of infrastructure. There's also good evidence that having a stream that's attractive and fun to play in increases human well-being and increases property values. For instance, I don't think this stream here is increasing that neighbor's property values. In arid areas, there are water reuse and groundwater recharge options. And as I already mentioned, it reduces stress on aging stormwater infrastructure and infrastructure overall in general, which can reduce cost in the long term. It also improves ecosystem services and aesthetic and cultural benefits. People tend to like wading access and fishing. So really, emphasizing these local benefits may be a better route to getting people invested in an MS4 program in their city. I then want to address this idea that we need to find large plots of land in some of these dense cities to build really big structures. For instance, most of the municipalities around Williamsport are pretty densely developed because the river valley is so narrow, and wedging in a huge project is difficult. So do we need to have a large project? First off, it's important to understand that our existing infrastructure is a product of historical development patterns and standards. So it's not necessarily what we build today, but it is what we have, and it oftentimes doesn't give the room or necessary areas to incorporate some of the more modern methods of stormwater treatment. Stormwater back then was managed primarily as a nuisance or as a safety and property threat, so you end up with ditches, pipes, and detention basins. And traditional structures, such as this detention pond, don't always address water quality well. For instance, I don't think that having this quantity of waterfowl is necessarily helping manage nutrients in a very effective manner. However, you can retrofit existing systems, but it may be too expensive to have an effective system. You may also not have BMPs that are present and able to be altered. I know the city of Williamsport doesn't have many, and there may be ownership issues if it's on private property. Enormous redesigns of entire stormwater systems with highly engineered structures like underground detention facilities are likely to be obsolete in the future as precipitation increases or other development continues, and they're incredibly expensive. So in some cases, small source control projects may be more effective. So parcel scale projects where you can get landowners on board. And in some cases, we found a couple cases that were really fantastic of retrofitting existing detention ponds and other BMPs if the land's available and ownership isn't an issue, to make them more effective and meet requirements. So the big issue here is that designs aren't one size. Sometimes you do need a large project, and sometimes your options are small ones. You need to consider your catchment characteristics, land use patterns, your existing infrastructure system, regional climate, and finances. It's incredibly context dependent, which makes it important to really evaluate your situation and find a solution that exists, because there are a ton of them out there. So with that, you can have large or small projects that are effective, and there are a variety of options depending on your situation. Next, I want to talk about monitoring, and this idea that if you monitor what you're doing or your BMPs and how effectively they're working, it's going to uncover some additional difficulty, and you're going to get in more trouble than if you had just not monitored at all. So we searched to see if people had gotten in a lot of trouble by monitoring their stormwater system, and we found no. Fines and fees are really only levied in cases of actual negligence. In most cases, any problems in an MS4 program end up with an opportunity to fix the noncompliance without paying the full fees that would normally happen. I know we're talking about audits later today, and I read quite a bit about them and how they've worked in other regions. They are time-consuming and expensive, but in a lot of cases, they created avenues for communication and helped municipalities find financial and logistical assistance from state and federal resources. So kind of a scary thing, but can be helpful at the end. We found that a lot of the problems that came up in audits were that programs lacked written plans, and actually not having monitoring programs caused more problems during an audit. So inspections are also important there, and having them as part of your written plans and your monitoring programs becomes important in the case of an audit. So monitoring actually helps you. We also found it's difficult when there's no standardized reporting form for some of these things, at least at a federal level. So it's difficult to know what you need to monitor or report on your progress, and that whole process can be confusing. For small municipalities in particular, there's a lack of manpower and other resources to effectively monitor and compile that data, which can cause problems with compliance, which is a unique aspect of that issue. So what we found is monitoring is good because it provides information on what's working well and how much you're spending and what's most cost effective, which can inform your future work. It also provides information to other municipalities if you share it, which can inform what you're doing in the future. So if you know that a nearby municipality had something that worked well, you can probably try it. And it also provides data to support you in the event of an audit. So it's a risk reduction strategy in that sense. And there are options that are low cost. For instance, remote sensing is particularly useful. Citizen science, for instance, we have a small army of interns this summer who are available to help with a lot of these projects. There's also the possibility for interdepartmental collaboration within the municipal government, in particular by maintenance departments, we found can provide valuable inspection because they're already moving around the city and they can stop and check on some of the BMPs and other infrastructure. And like I said, you can incorporate citizens or higher educational institutions to make it a mutually beneficial partnership and have your system monitored at a low cost. So monitoring can inform your future planning and can improve project success, in particular by protecting you in the case of an audit. And perhaps the biggest issue that we found is that funding is always an issue, and the MS4 program did not come with direct federal funding, and that's perceived by a lot of small municipalities as making these regulations absolutely insurmountable. And we named this the unfunded mandate problem. There's no direct funding, causing an undue burden for municipalities, some people say. Many programs have no dedicated funding, and these programs can be very expensive. But we heard rumors about people thinking their cities were going to go bankrupt from stormwater projects. And we searched and searched trying to find cases of this happening. And we found that this has never happened due to stormwater. It has wastewater infrastructure, and in particular combined wastewater systems or other aging wastewater systems, have bankrupted small cities. So addressing stormwater could alleviate some of the pressure on your wastewater system potentially, and avoid that risk. And really, at the end of the day, with no direct funding, creating some funding source requires some really innovative methods. Grants are a terrific option, although there is a challenge with having someone with the time and resources to apply for a grant. Taxes can be effective where legal. Almost every successful stormwater program we found levied stormwater utility fees, just because it creates a continuous revenue source to do the standard maintenance that can then be supplemented by, for instance, a Growing Greener grant or a similar program. There are also market-based mechanisms that can help convince individual landowners to allow projects on their property, for instance, reverse auctions, which I'll talk about a little bit later. And then collaborating with other municipalities in something like a stormwater coalition or similar is just incredibly useful, because you can pool your resources for maintenance, you can pool your public education curricula and have those events timed together, and just overall save money by perhaps hiring one engineer to look at multiple municipalities so that it's a little bit less expensive for each municipality. At the end of the day, just like designing your BMPs, you need to tailor the funding strategy to the socio-political situation in your municipality. So if you have a really green-minded community, it's a little bit easier to incorporate a higher stormwater utility fee, which may allow you to accomplish more without having to apply for a grant. And market-based mechanisms may be a no-go in some neighborhoods where people really value certain components of their property. So at the end of the day, these misunderstandings or barriers can really hamper focusing on the general idea that we need to focus on how to get around the problem and come up with compliant MS4 programs. And what we found is that we really need to demonstrate to the community the ecological relevance of urban stormwater, benefits to local stakeholders, flexibility of project size, and the potential benefits, or at least the lack of risk, to monitoring, and that the funding barriers are really surmountable. And overall, the key characteristics of effective stormwater programs were dynamic, creative funding mechanisms, horizontal and interdisciplinary collaboration, effective public education and involvement, and extremely careful planning and execution of BMPs. So really considering what you want to treat specifically and finding something that will do that. So now I want to go through some examples from the literature. And the first really goes over just in general through a large number of outreach programs that address the whole upstream only, it's agriculture's problem, and the lack of local benefits challenges. And we found that the key is to really meet constituents where they're at socially, financially, and politically. You're not going to get anywhere by discussing a benefit that doesn't matter to your community. So that really you need to change the tone depending on who you're meeting with, which can be a challenge in some cases. And it's important to remember that there is credit for every educational and outreach event that you do, and collaborating with other institutions to have those events can increase attendance and really help you out. We did find a need for more research on effective communication on the intersection of human-generated stormwater, surface water ecosystems, and human well-being, so that this could really be communicated. And then to take that information and develop these transferable, easily deployable educational tools that can be used across municipalities and regions. So if there were better resources for small municipalities to create these outreach programs to satisfy their public education and outreach MCMs, that would really help if there was some kind of a blueprint. We also found that it's extremely helpful to partner with outside institutions such as watershed groups, higher education, and extension services to help defray cost and create more effective programs. These institutions also tend to be already plugged into constituents who would be interested in stormwater to begin with and can increase attendance. As an example of a program that was extremely successful and how important it is to know your particular system, Western Michigan University has an MS4 program, which is an extremely small MS4. And they were under a TMDL for phosphorus load. And they used state and federal grants to directly recalculate the required phosphorus reduction they needed. And they actually found that previously installed, just through the course of capital improvements, infrastructure, as well as some stormwater retrofits that they incorporated in the course of already funded capital improvements, allowed them to recalculate their load, and they met their TMDL ahead of schedule and at lower than estimated cost by rolling it into capital improvements. So really looking at your system and making sure that all of the calculations are accurate help them out in this case, and spending that grant money to recalculate the load helped them out tremendously. In two examples, a really unique funding mechanism was used in predominantly residential areas with very little space for a larger BMP. So Little Stringy Bark Creek and Shepherd Creek, the first in Australia and the second in Cincinnati, Ohio, are really densely populated residential areas where a traditional BMP like a detention pond or a constructed wetland really wouldn't fit because there's no public land available. And here, in both cases, they obtained grants to kind of demo a market-based incentive that was a reverse auction to encourage homeowners to install rain barrels or rain gardens on their properties. So for each property, kind of like how a lot of stormwater fees are calculated, they calculated an environmental benefit index for each property, calculating essentially how much phosphorus and nitrogen and sediment could be reduced if a rain garden was installed on that property. They then allowed homeowners to submit bids, essentially saying how much they'd be willing to be paid to have a rain barrel or rain garden placed on their property, and there was a fixed total cost for the project. So then they took all the bids that had been submitted and figured out how to maximize the environmental benefit index per unit cost of dollars spent. And this helped tremendously in navigating private property issues. They installed all of the rain barrels and gardens they wanted to, and homeowners were actually pretty compliant with keeping up with maintenance. The keys in getting this to happen is that both projects were facilitated by non-governmental groups. One was, I think, University of Cincinnati, and the other was a private watershed group working on behalf of the government to do the outreach and educational components to get homeowners interested. And the post-project surveys in both cases suggest that having a neutral party communicating the message really increased homeowner confidence in the program. The other key to these programs is that they were funded by large grants, both to pay for the rain barrels and rain gardens and to pay the homeowners for them. So this is a pretty complicated type of project that would best be addressed when someone is available to gather the information and apply for grant funding. And in an example of how important coalitions and partnerships can be, it's a little bit far away, but Hamburg, Germany, Germany has similar stormwater regulations for most of its cities compared to the US. And there, the city collaborated with the state environment ministry to form an enormous task force specifically for stormwater in Hamburg. And they took engineers, ecologists, geospatial analysts, and urban planners and created this enormous GIS database to allow information and expertise from all of these individuals to really inform best actions. So they have this great database that allows them to really analyze where they should be taking action for the most effective projects given a budget. So these interdisciplinary partnerships can increase expertise and really improve outcomes, but even this group struggled, and I'm not sure if it's actually still around. They were trying to reform the last I checked in. And these partnerships can be challenging. It's really hard to keep a partnership equitable, beneficial to all parties, and address all of the local sociocultural concerns. And we've seen that around here, that just there's a lot of different interest whenever you have collaboration. But they can be tremendously useful. Even if they're not long-term partnerships, you can accomplish something by trying. So I wanted to leave a little bit of time for questions, but in general, the conclusions we found are that community-specific factors are enormously important when implementing stormwater programs. So just because it worked somewhere else does not mean it's going to be effective in another municipality, particularly with small municipalities that are so unique geographically and sociopolitically and financially. The monitoring needs, funding options, and social and physical characteristics of communities vary so greatly that each municipality really needs to be considered as an individual case. Small municipalities, however, would benefit from toolkits and partnerships that help find and choose appropriate funding, help them identify potential BMPs that would fit in well, and also connect them with at least frameworks for effective outreach programming, if not actual outreach materials, just so that there's not this concern about finding an employee solely dedicated to finding grants or to planning and executing outreach activities, or any of that additional work that many small municipalities don't have a dedicated employee to cover. And with all this, interdisciplinary work and collaboration can help address all facets of the challenge of urban stormwater management. So with that, as Dr. Zimmerman said earlier, we're working on this project with some generous funding from the Arthur Vining Davis Foundations. And I really want to thank everyone I've been able to talk to in the past few years concerning the challenges that small communities face when trying to address stormwater. So.
Thank you. So at this point, we have about 5 minutes left for questions, and I see some in the chat. If folks have questions for Dr. Zimmerman and Dr. Reich, please put them in the chat and we'll get to them in the next 5 minutes. I'll go ahead and share the first question. Could you share more about the urban per acre bang for the buck? I think most of the messaging municipalities get is that there is more bang for the buck on agricultural lands.
So I think that that's a pretty common perception, and I think part of it has to do with the types of restoration and mitigation that are used on agricultural versus urban land, because it's fairly easy to find a farmer who has, say, 200 acres of land and only one stream and put in riparian buffers, and that reduces the sediment load and does a fairly good job of it. And riparian restoration is fairly easy because you revegetate it and you have your riparian buffer. I think that the issue there is an acre of urban land is such a large area proportionally that really, if you are treating an acre of urban land, you will reduce more sediment and nutrients than from an acre of agricultural land. So the BMP is more difficult to envision and more difficult to install. But if you treat a whole acre of urban land, it will give you more reduction. So it's a per acre issue. It's not that it's just relatively, if you treat an acre of urban land, it will reduce more nitrogen and phosphorus than if you treat 1 acre of agricultural land. I think that part of it is that we tend to think of agricultural land in acres and we don't think of urban land in acres. So it's harder for people to understand how to treat that.
Okay, great. Does anybody else have a question they want to put? So the response to that was it's helpful framing. So thank you for your answer to that. I have a question if other folks don't have any that they want to put in the chat or while they're thinking of it. You talked about community factors, community specific factors being so important. And I'm wondering if you all have thought about putting together any sort of a municipal characterization checklist, or if anything is like that out there that sort of, if your characteristics are X, Y, and Z, these possible solutions might be good for you. Because you talked about toolkits, so that could be a helpful thing in the toolkit.
Yeah, I mean, I think that would be helpful. I think, part of the issue is, can you classify a community that easily? I mean, in a way you can. I think one of the big things is the biggest factor is understanding how financially stressed your community already is. Because if people are struggling with their bills already, trying to engage them over, there are a lot of concerns that people really don't care about when they're already struggling to pay their own bills. So as stormwater fee seems extremely onerous if you have a large proportion of low-income residents. So that could certainly, I'd say the first thing to understand is the financial situation. But yeah, I would think any public outreach materials probably should be catering to specific demographics, and maybe that's something we'll have to take into account as we develop more outreach materials.
Great. I think the comment about the financial situation is very astute. So another question came in, what kind of BMPs have been successful in Lycoming County?
I can try to address that a bit. All of the municipalities in Lycoming County are basically in their early stages of implementing their BMPs and basically getting the permit to address those particular issues. So you find a range of things. Initially, they were trying to find a number of locations which are hard in the urban area to do riparian buffers, some of the same BMPs that are used in agricultural areas. One of the things that we've been working on is a GIS-based examination of some of the municipalities to find out where there might be some undeveloped areas or green spaces that might be able to be worked up for some BMPs that might be working on some of these urbanized streams. But there's a combination of different, swales or upgrades of where these outflows are to be able to retrofit some of them to be able to handle some more infrastructure that could be put in for infiltration and things like that. So one of the things we're going to be hopefully doing here is working with the partners to start doing a comprehensive list that could be shared. So we're hoping to have some open meetings over this next year. We were hoping to do some last year, but because of COVID, we weren't able to do that. But also launch a website. I know different municipalities have websites where they address stormwater, but maybe having a sort of a third person neutral party where we can post different things and help with the education outreach is our goal.
Great. I'm just looking at the time. We are supposed to leave here and go into the plenary within the next 3 minutes. So I want to thank our voluntary speakers today, Dr. Reich and Dr. Zimmerman. If everyone can show a little appreciation using the emojis, and applause and thanks and thumbs up. Thank you so much for your time today, and thanks to all of our participants. We appreciate you all being here. At this point, we're going to exit this session and go back into the plenary using the links. I don't know, Liz, if you're going to put links in here, if everyone can go back to their agenda. And we're going to move into the BMP case study portion of the morning. Thanks so much, Dr. Reich and Dr. Zimmerman, for your time. We'll see everybody
And
back
the
in the
links,
plenary.
they're now.